Download this code from codegive.com, link in the description below. OK, let's dive deep into addressing data corruption problems, focusing on real-world visual novel, VN, code scenarios and providing practical code examples, mostly in Python, as it's often used in VN scripting and data manipulation. This will be a comprehensive guide to understanding, identifying, and fixing data corruption issues. Understanding data corruption. Data corruption occurs when the integrity of data is compromised, leading to inaccurate, incomplete, or unusable information. This can happen due to a variety of reasons. Hardware failures, bad sectors on hard drives, memory errors, power outages during write operations, faulty network cards. Software bugs, programming errors, improper file handling, incorrect data conversions, race conditions in multi-threaded applications. Transmission errors, network issues, faulty cables, interference during data transfer. Human error, accidental deletion, overwriting files with incorrect data entry. Malware/viruses, malicious software can intentionally corrupt data. Impact in visual novels. In the context of visual novels, data corruption can manifest in several ways. Corrupted save files. Players lose their progress, the game might crash when loading the save. Missing or glitched assets. Images, audio, or video files might be damaged, leading to graphical or audio errors. Corrupted script files. Dialogue might be missing, events might not trigger correctly, the game might crash due to syntax errors or unexpected data. Corrupted game configuration. Settings are reset or invalid, causing unexpected behavior. 2. Identifying data corruption. The first step is always identifying that a problem exists and suspecting data corruption. Here's how. 1. Symptoms. Crashes. The game consistently crashes in specific locations or when loading certain files. Errors. Error messages appear indicating file not found, invalid format, checksum errors, or I/O errors. Glitches. Visual or audio artifacts, missing images, strange behavior. Missing data. Save files are gone, dialogue is missing, options are reset. Unexpected behavior. The game behaves in ways it shouldn't, example characters doing things out of sequence, wrong values displayed. Slow performance. If the game is trying to read corrupted data, it might repeatedly try and fail, causing significant slowdown. 2. Reproducibility. Can you reproduce the error consistently? Is it random, or does it always happen when loading a specific save file? Reproducible errors are easier to debug. 3. Error logs. Check the game's error logs, if any. Many VN engines will write logs that can provide clues about what went wrong, file names, specific errors. 4. File integrity checks. If you suspect a specific file, use file integrity tools, checksum calculators, to verify if it matches the expected checksum. If you have a backup of the file, compare its checksum to the current version. Checksums, MD5, SHA-256. A checksum is a hash value calculated from the contents of a file. If the file changes, the checksum will change. Example, Python. 3. Common data corruption scenarios in VNS and solutions. Let's explore some common scenarios and how to fix them. 1. Corrupted save files. Cause power outages, bugs in the saving/loading code, disk errors. Solutions. Asterisk implement checksums in save files. Asterisk when saving, calculate a checksum of the saved data and store it in the save file. When loading, recalculate the checksum and compare it to the stored checksum. If they don't match, the save file is corrupted. Asterisk backup save files. Asterisk implement automatic backups of save files at regular intervals. If a save file is corrupted, you can revert to a previous version. This can be a simple copy operation to a backup directory. Asterisk error handling. Asterisk wrap the save/load code in try, except blocks to catch potential exceptions, example IO error, value error, and provide informative error messages to the user. Avoid crashing the game. Instead, prompt the user to load a different save or start a new game. Asterisk data validation. Asterisk before saving, validate the game data to ensure it's in the correct format and within acceptable ranges. This can help prevent corrupted save files due to invalid data being written. Asterisk atomic writes, advanced to minimize the risk of incomplete save files due to power failures, consider using atomic writes. This involves writing the save data to a temporary file and then atomically renaming it to the final save file name. This ensures that the entire save operation either succeeds or fails, but never leaves a partially written save file. This is platform specific. For example, the os.replace in Python is often an atomic operation. Check your OS documentation. Asterisk consider a database, more complex for more robust save systems, especially in larger VNS with lots of data. Consider using a lightweight database, example SQLite. Databases provide ACID properties, atomicity, consistency, isolation, durability, which help ensure data integrity. SQLite can write to a single file, making it relatively easy to manage. 2 corrupted image/audio/video assets. Asterisk cause download errors, disk errors, file transfer errors. Solutions. Redownload assets. If possible, redownload the assets from the original source. This is often the easiest solution. Restore from backup. If you have backups of your project, restore the corrupted asset from the backup. Image repair tools. Some image repair tools, online or desktop software, can attempt to fix minor corruption in image files. Be cautious when using these, as they may not always work and could potentially further damage the file. Re-encode/convert. Try re-encoding or converting the asset to a different format using a reliable tool. This may sometimes fix minor corruption. For example, you might convert a corrupted PNG to a JPEG, then back to PNG. Checksum verification during loading. If you have a checksum for each asset, calculate the checksum of the asset when it's loaded and compare it to the stored checksum. If they don't match, display an error message, or use a placeholder image/audio, instead of crashing. Implement redundancy, advanced in critical applications, not usually necessary for VNS, but technically possible. You could use techniques like RAID, redundant array of independent disks, to store multiple copies of the data. This provides redundancy in case of disk failures. 3 corrupted script files. Cause typos, incorrect syntax, encoding errors, example using the wrong character encoding. Solutions. Syntax checkers. Use a syntax checker or linter for your scripting language. These tools can automatically detect syntax errors and other potential problems. Version control. Use version control, example Git, to track changes to your script files. This allows you to easily revert to a previous version if a script file becomes corrupted. Asterisk encoding awareness. Asterisk ensure that your script files are saved with the correct character encoding, example UTF-8. Inconsistent encoding can lead to character corruption. Asterisk error handling. Asterisk implement robust error handling in your scripting code. Catch exceptions, example value error, type error, index error, and provide informative error messages to the user. Asterisk data validation. Asterisk validate data read from external files, example CSV, JSON, to ensure it's in the correct format. This can help prevent errors caused by unexpected data. Asterisk backup. Asterisk keep backups of your script files. Asterisk diff tools. Asterisk use a diff tool to compare the corrupted script file to a previous version or a backup to identify the changes that caused the corruption. Asterisk logging. Asterisk implement detailed logging in your scripting code. Log important events, function calls, and variable values. This can help you track down the source of errors. For corrupted game configuration. Asterisk cause incorrect user input, bugs in the configuration saving code, file system errors. Solutions. Input validation. Validate user input to ensure it's within acceptable ranges and in the correct format. Default values. Provide sensible default values for all configuration options. If a configuration value is corrupted, you can revert to the default value. Configuration file validation. Implement a mechanism to validate the integrity of the configuration file when the game starts. If the configuration file is corrupted, you can either restore it from a backup or reset it to the default values. Separate configuration file. Consider using a separate configuration file for user-specific settings. This prevents game updates from overriding user preferences. 4. General best practices to prevent data corruption. 1. Regular backups. Create regular backups of your entire project, including all assets, script files, and save files. Store backups in multiple locations, example local drive, external drive, cloud storage. 2. Version control. Use version control, example Git, to track changes to your project files. This allows you to easily revert to a previous version if necessary. 3. Hardware monitoring. Monitor the health of your hardware, hard drives, memory, using diagnostic tools. Replace failing hardware promptly. 4. Power protection. Use a UPS, uninterruptible power supply, to protect against power outages. 5. Software updates. Keep your operating system, drivers, and development tools up to date. Updates often include bug fixes and security patches that can help prevent data corruption. 6. Safe file handling. Use proper file handling techniques in your code. Always close files after you're finished with them. Handle exceptions gracefully. 7. Testing. Thoroughly test your game, especially the save/load functionality. Create test cases to simulate various scenarios, including power outages, disk errors, and invalid user input. 8. Code reviews. Have other developers review your code to identify potential bugs and security vulnerabilities. 9. User feedback. Pay attention to user feedback and bug reports. Users may report data corruption issues that you haven't encountered during testing. 10. Antivirus software. Use up-to-date antivirus software to protect against malware and viruses. Debugging strategies. 1. Isolate the problem. Try to narrow down the source of the corruption. Is it a specific file, a specific game area, or a specific action that triggers the problem? 2. Step-by-step execution. Use a debugger to step through your code and examine the values of variables. This can help you identify where the data is being corrupted. 3. Print statements / logging *, add print statements or logging to your code to track the flow of execution and the values of variables. 4. Binary search *, if you suspect a specific section of code is causing the problem, try commenting out parts of the code to see if the problem goes away. This can help you narrow down the offending code. 5. Memory analysis tools * for more advanced debugging, you can use memory analysis tools to examine the memory used by your game. This can help you identify memory leaks or other memory-related issues that could be causing data corruption. 6. Real-world VN code examples, beyond Python. While Python is great for tools and support code, VN engines often use their own scripting languages. Here are some hypothetical examples of how to apply the concepts to those. 1. RenPy, Python-based. 2. Unity, C scripting. * Key points in the Unity example *. JSON serialization * uses JSON utility for saving and loading data. * SHA-256 checksum * employs the SHA-256 algorithm for checksum calculation. * save/load methods * save game saves the game data with the checksum, and load game loads it, verifying the checksum. * error handling * includes checks for file existence and checksum mismatch. 7. Conclusion. Data corruption is a serious issue that can affect any software, including visual novels. By understanding the causes of data corruption, implementing preventive measures, and using debugging techniques, you can minimize the risk of data corruption and create a more robust and reliable game. Remember to prioritize data validation, error handling, and regular backups. The specific techniques will vary based on the VN engine you use, but the core principles remain the same. Good luck.